Hey guys, we're going to talk about resistors and capacitors placed in series and parallel and see what happens. Sometimes it's confusing, but we're going to get a charge at it and we'll see where it leads us. Are you ready? Let's go. So for this thing, I'm going to pick on the Phet simulation. That's very useful because you can see the charges actually moving. So here I put a 9-volt battery in parallel with a resistor that is 10 ohms and a light bulb that's also 10 ohms. And then I have two capacitors over here. One is 0.1 farads and one is 0.2 farads. All right, so right now I have all the switches open. So what do you think is going to happen when I start opening and closing these switches, huh? Interesting. There'll be some questions that follow up on this video, so you can go back and watch and then see if you can answer the questions. All right, so first thing I'm going to do is I'm going to close this switch over here, and then we'll see if this battery can do anything. It looks like everything is otherwise closed. So, all right, here's close the switch, and woo! We got lights, and they're moving very slowly. So here are the charges moving very slowly through this resistor over here, and then through the light bulb, lighting up the light bulb. All right, so we could also measure voltage and see like how much voltage is on the battery, on the light bulb, and you can also look at like you can take the voltage and probe it as it goes along. So right now I have the probes backwards, so this is the minus side. Here's the plus side. All right. And apparently the Phet is showing the simulation of these little bubbles going around. And looks like the bubbles are moving away from the minus side towards the plus side. So what do you think those are? Minuses or pluses? Electrons or protons? All right, so I'm going to move my little red probe here. So right now it says 9 volts, 9 volts, 9 volts. So we haven't lost any energy. And then we get to the light bulb, still 9 volts. But then after you go through the light bulb, now we have 4.5 volts left. So we lost some voltage going through the light bulb. There's a voltage drop because the light bulb is dissipating some energy. Electrical energy is turning into light energy and heat energy. All right, so I keep continuing on here. The resistors, the wires have no resistance really in this simulation, so I'm not losing any voltage yet. I get to this resistor, and then it's going to lose some voltage. I wonder how much. So that might be one of the questions. All right, so I'm going to just keep the voltage probe on this light bulb right now and see that it's 4.5. And the way I put the black and red probes there, it looks like it's like negative 4.5 because we're actually showing how it lost the 4.5 volts. All right, now let's open up the switch and see what happens. So, whoops, let me try to open the switch. Give me a little switch, there we go. And oh, there's no more voltage on the light bulb. Even if I switch it this way around, it doesn't matter, there's no voltage on the light bulb. And there's also no voltage probably on this resistor because they're not like batteries or capacitors. They can't store energy. They just get rid of energy. Hold on a second. All right, now let's change things around and see what if what if we close this switch? So now we got voltage. All right, now what we're going to do is we're going to open. Oh, the switch is already open. Oh, we're going to close this switch. Ooh, what's going to happen then? What do you predict? So when I close this switch, do you think there will be some current going through this resistor and light bulb? So recall that when you first open up a circuit to a capacitor that doesn't have any charge, these act as wires, like there's no resistance, so there's going to be a surge of current going through these capacitors. And after a long time, these capacitors will charge up and eventually block any current in their path so that eventually they'll have the right amount of voltage so there will be no current in this little wire here. All right, are you ready? It's going to be crazy. Closing the switch. Oh, here we go. Close, 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 slowly. Oh dear. Did you see that? All right, so now very quickly these capacitors are charged up. There's no current going in through here. And it appears there is no current. Is there current going here? Oh, look at that. There's just a little bit of current going through the light bulb, just like before. Or is it like before? Does it seem slower to you or faster? You might have to rewind the video and see. But there is current going through this resistor and this capacitor, but there's no current over on the right side of the circuit where there is the capacitors. All right, so now let's check out the light bulb. How much voltage does it have? So it has lost, let's see, it's 9. It's looks like 4.5 again. So basically the circuit is the same it was before. All right, but now we have these capacitors. These capacitors have different amounts of capacitances. So this one's only 0.1 farads. This one is 0.2 farads. They both are in common with something. What do they have? Do they have the same charge or voltage? So let's figure that out. And you can kind of look at the picture here and see that the minuses and pluses, what they look like, give you an idea of the charge. But let's just pick on one of them and see what is the voltage. So let's pick on this one, the 0.1 farad. Do you think that one will have more voltage, less voltage, or the same as the other capacitor? And will it add up to 9 volts or be something different? So this one is 6 volts. Interesting. And this one over here, can you guess what it's going to be? It is 3 volts. So one has 6, one has 3. They are in parallel with the resistor and light bulb. So altogether, if you look at either corner here, so if you go to this corner over here, so this is 9 volts, which is in parallel with the battery. So this whole middle line has 9 volts, and then so does through our capacitors. But you call which capacitor had more voltage? Was it the less capacitance or more capacitance? And do they have the same charge or not? Something to think about. All right, now we're going to do one last thing, a little crazy. So let's get crazy. We're going to open up this switch so the battery is no longer working. Let's grab this. Oops. Oops. Hold on a second. Let me grab that little switch there. Come here, you little guy. Oops. Second here. Grab it. There we go. All right, open the switch. There's the switch opening. And now what's going to happen? Looks like we're losing voltage. It's going from 9 down to 0. Why would that be? Oh, look at our charge. Our charge is disappearing. Where is it all going? It was charged up and it's slowly. Charge is moving off the capacitors. Where did it go? It can't go through the capacitors, so somehow the charge must go off the capacitors, through the wires, through these resistor and light bulb. It's not lighting up the light bulb, but there's a slow amount of current going through there, very slowly. And we can see that it's gradually the voltage is dropping to 0 volts. And gradually the charge disappeared off the capacitors. So we discharge the capacitors through this little circuit on the right. And we have a certain amount of voltage, and so we'd have a certain amount of current at first, and then the current decreases as more and more of the energy goes into the light bulb, into the resistor as heat. And the energy that was stored in the capacitor is now pretty much gone. It has almost 0 volts after just a minute or so. So there's a very beginning current, and then at the end, there's no current. All right. Hope this helps you understand resistors and capacitors and how switches can change where the energy is flowing. Good luck.